Hi, I'm Cherry, and I'm a rock. Most people don't know that there's more to us than what meets the eye. Everyone just so easily calls us, Mommy, look, a rock! But we're not all just rocks, you know. Just like not all of you are just Asians. There's the Chinese, the Malaysian, and the Filipino. Let me show you who we are so the next time you see a rock, you'll know the right way to call it. Especially rocks from our certain tribe, the Sedimentary. Before I introduce you to the Sedimentary tribe, I want to introduce you to the other two tribes who represent the rocks, the Igneous and the Metamorphic. The Igneous tribe are the natives, and they're from down there, very traditional if you ask me, but we love them just the same. The Metamorphics, on the other hand, are a mixed race. Their forefathers, even the rocks from this age, like to marry rocks from different tribes, so usually the Metamorphics my age have a mix of igneous or sedimentary, and of course, metamorphic. Oh, and how about us, you ask? Well, let me just start off by saying that we've got through a lot. And by a lot, we literally mean a lot. If endurance was spelled differently, it would be Sedimentary. Ha. So, who exactly are we? Our tribe name Sedimentary comes from the Latin word sedimentum, which means settling. Although we're all from the same tribe, we still have different origins. Some come from pre-existing rocks, from precipitation, or from interaction with other elements in nature's life processes. And then, from that point of origin, starts the real journey of how sedimentary rock comes into the world. There are 5 processes that lead to the conversion of sediments to a sedimentary rock. Think of it like your life stages from birth to adulthood. We start with weathering. Weathering is the physical disintegration and chemical decomposition by which rocks are changed upon exposure to the physical, chemical, and biological processes occurring at or near the Earth's surface. This all occurs in place. There are 2 ways in which we can be weathered, either through mechanical means or through chemical means. Mechanical weathering includes ice or front wedging, salt crystal growth, sheeting or unloading, and organic activity. In chemical weathering, on the other hand, there is new material produced, which is either made through hydrolysis, oxidation, or dissolution. After being weathered, we then go through erosion, the next life stage. This is the forceful physical removal of materials from the parent rock mass that is usually accompanied by transportation and eventually ends in deposition. Did you know that there are 7 agents in this world tasked to ensure that we get eroded? And they are Mr. Wind, the twins, groundwater and running water, the glaciers, Mr. Wave and Mrs. Current, our lovely animal and plant friends, and of course, last but not least, powerful Mr. Mass Wasting, or more known as Uncle Landslide. The next stage, though, is called transportation. This is the movement of materials from one place to another. It's the stage where we get our characteristics, our defining features, where we get our good looks from. Unk. The rounding of particles happens where the sharp edges get worn out as we get transported through varying distances. And as we say in the Sedimentary tribe, beauty is in the eye of the beholder. So, whether you've been transported far enough and get smaller and rounder features, or transported just enough and get larger and more angular features, we from the Sedimentary tribe believe that you are beautiful in your own way. The next stage in our life is called deposition. It is characterized by settling and the weakening of agents. This is where a vital process called sorting happens. Sorting is like the separation of materials according to size, shape, and specific gravity. Just like in rounding, we don't all get the same result. Others get well sorted while others poorly sorted. And then the last stage comes in, which is called lithification. This is a stage we go through before we become a fully developed sedimentary rock. It's the general process that would lead to the consolidation of sediments to sedimentary rocks. There are 2 processes by which we are lithified: cementation and compaction. Compaction happens when the sediments get pushed together and then they undergo partial dissolution, which then leads to our compaction. Cementation, on the other hand, happens because of the mixing of water and soluble materials like silica, carbonates, and iron oxides. This cement solution then goes into the spaces between our fragments, and once they harden, we get consolidated and we are all born into the world. Oh, I shed a tear. My Lala also always gets teary-eyed when he gets to the end of the creation story. Okay, moving on. In the rock world, did you know that we don't have a gender classification? What we do have, though, is texture classification. You are either made clastic or non-clastic. The clastics are sedimentary rocks that are defined by their discrete fragments and particles, which are very visible, so you won't have a hard time distinguishing them from the other non-clastics. These particles can either be from rocks, minerals, fossils, or glass that got clastos. That means broken in Latin. The origin of the word clastic. The non-clastics have no visible particles. They sometimes look like clumped sugar and have minerals forming an interlocking crystal pattern. A more in-depth classification of texture is discussed when we talk about biochemical sedimentary rocks and the detrital or fragmental sedimentary rocks. Biochemical sedimentary rocks include both clastic and non-clastic textures. They are formed by direct precipitation of minerals from solution or derived from life processes. In biochemical sedimentary rocks, the composition is more important. Those with non-clastic texture are usually composed of sediments from precipitation or secretion of organisms, while those with clastic texture have a composition of fragments from fossils or corals. Here's a table showing you names of my close friends. Limestone is a good friend of mine, but she easily gets sick whenever there's HCl around. I guess she's allergic. Her parents say it's in her genes. She's made of calcite, you see. In the sedimentary tribe, there are lots of other rocks named limestone too. Others are clastic, while others are non-clastic. The clastic texture of limestone is defined in the presence of shells, shell fragments, or microfossils. Other limestones who are non-clastic, on the other hand, have medium to coarse interlocking crystals formed with inorganic channel precipitates. Limestone's distant cousin, dolostone, is also a bit allergic to HCl, but not as much as limestone. However, when he gets powdered, the HCl gets to him for sure. Dolostone is made of dolomite, which is the reason why most people call him dolomite too. Our good friend rock salt, on the other hand, is small but terrible because she has a superpower. She's made of halite and sodium chloride, and her particles range from fine to coarse crystalline. And wanna know what her superpower is? She has a salty taste! So feel free to have a lick whenever you come across her next time. Rock gypsum, on the other hand, likes to take after rock salt. But even if she's fine to coarse crystalline composition as well, she's soft. She is made of gypsum, as what can be assumed from her name. Coal, on the other hand, is our emo one in the group. He likes wearing black too. I guess you can't help but be moody all the time when you're always misunderstood. I mean, people always think he's one and the same with charcoal. Coal is special, okay? He's not like charcoal, who's very pretentious. Charcoal's not even a rock. Charcoal is just burnt wood. Coal comes from the consolidation of altered plant remains. See? Very special. I actually think he's dealing with all his issues well, since he still gets to help the world get its energy through him. He has to fix his issues soon, though. Otherwise, the world won't be able to handle his harsh tendencies anymore. Especially when he gets a little angry. Oops. Global warming. Hey, sorry, Cole. Anyway, we're not forgetting anyone, are we? Anyone starting with letter C? Just kidding, of course. Of course I'm gonna talk about me, myself, and I. Maybe you've been wondering what kind of sedimentary rock I am. Well, Cherry is just actually my nickname. My real name is actually Chert, but that's too boring for me, so I asked people to call me Cherry instead, and it caught on. I, like other non-clastic rocks named Chert, am cryptocrystalline, dense, and I have a conchoidal fracture, which is just a fancy way of saying curved. Classic variations of rocks named chert, on the other hand, are made of shells or microfossils, and they also have a conchoidal fracture. We are all made from microcrystalline quartz, or SiO2. Yep, we're an interesting bunch. If biochemical sedimentary rocks are broader in their texture classifications, detrital sedimentary rocks only include those of clastic texture. The primary basis for being distinguished as detrital is the particle size. They are usually formed from the weathering and erosion of pre-existing rocks. The common sediment name for the particles boulder, cobble, pebble, and granule is gravel or rubble. If you have silt and clay particles, your common sediment name is mud, and if you have sand particles, well, you still get called sand. Apologies, my friend, no distinction for you. Quick trivia! Did you know that when geologists want to confirm whether a sedimentary rock is a siltstone or a claystone, they use their tongues to do it? That's right! This is called the tongue test, and if you let your tongue rest on the rock for 5 seconds and you experience drying, much like what you experience when you eat that chit-chat from Chowking, then the rock is a siltstone. Absence of this feeling in your tongue, however, confirms a claystone. The reason why your tongue experiences a drying sensation once it interacts with a siltstone is because siltstone has bigger pores or bigger particle sizes than claystone. Why, what kind of particles distinguish siltstone from claystone anyway? Here are the different particle sizes present in sedimentary rocks. I present to you the Uden-Wentworth size classification table. The Uden-Wentworth classification table groups the particle sizes into 7 categories in decreasing order, from boulder, cobble, pebble, granule, sand, silt to clay. The 4 categories at the topmost of the list, boulder, which includes particle sizes greater than 256 millimeters, cobble, particle sizes from 64 to 256 millimeters, pebble, 4 to 64 millimeters, and granule, 2 to 4 millimeters, are all grouped into a common sediment name. If your particle size ranges from 2 millimeters to more than 256 millimeters and you have rounder grains, then you're a conglomerate. You are a breccia, on the other hand, if you have 2 millimeters to 256 millimeters particles and you have angular grains. If you have sizes of particles that range from 1/16 to 2 millimeters, then you are a sandstone, and you are made of sand particles. Sand particles are all very varied in their own way, so they have subcategories. They can either be fine, medium, or coarse sand. The compact sedimentary rocks siltstone and claystone are meanwhile made of silt and clay, which range from 1/256 to 1/16 millimeters and less than 1/256 millimeters respectively. Other sedimentary rocks that are also made from silt or clay are shale, which exhibits facility or appearance of layers because it has an unusual weathering process, and mudstone, which is usually seen in blocks. Our distinction story from the other 2 tribes, our own creation story, our texture classification, and particle size classification, when put together, all define who we are as a tribe, diverse in our own little ways, but united in the ways that matter. We go through a lot, but we're proud to have come out stronger and better than most. I hope you got inspired by us and got to know us rocks a little bit more. Promise me the next time you see a rock, you'll spend at least a second to discover if it's from our tribe, will you? Who knows? Maybe you'll bump into me. I'm Cherry the Rock, and I'm proud to be sedimentary. Till next time!